Helo Code is a powerful, open source AI coding assistant.
Alright then gang, so we've seen the basics now of how Node runs on a computer, but to what end? Well, ultimately, we want to create a website whereby the server-side code is powered by Node and JavaScript. So our server will be the thing listening for incoming requests from a browser. But how does this whole process of communication between a browser and a server work? Well, on a simple level, we type a website address into a browser and then we hit enter. That sends a request to the server that's powering that particular website. The server then looks at that request and it decides what to send back to the browser. Now, in most cases, that will be an HTML page, and then that is then displayed in the browser. But it could also be images or CSS or JSON, anything coming from the server as a response. So when we type in a web address or a domain name into the browser, how does the browser then know to send a request to the correct server? Because there's probably millions of servers powering millions of different websites on the internet, but somehow the browser magically knows to connect to the correct one. Well, to answer that, we need to know a little bit about IP addresses and domains. So IP addresses are like addresses for computers which are connected to the internet, and all computers connected to the internet have a unique IP address to identify it, even yours and mine. Now, some special computers are known as hosts, meaning they host websites on the internet, and if you create and publish a website, it will be hosted on a computer somewhere, and that computer will have an IP address to identify it. Now, if we want to connect to a server on that host computer, we need to know its IP address to do it. We could then type that IP into a browser if we wanted to in the address bar to connect to our server. Now, IP addresses are just a series of numbers, right? And they would be really hard to remember, especially if you want to remember a few of your favorite different websites. So instead, we use domain names to mask these IP addresses. And then when we type a domain name into a browser and hit enter, it will find the IP address associated with it. And then it will use that to find the computer hosting the website and communicate with that. And this way it can send requests and get back responses to and from it. So say, for example, we type in the netninja.co.uk into the browser and then we hit enter. Well, then the browser will look up the IP address associated with that domain, and it will then use the IP address to connect to the server on the host computer with that IP. So then the server will then look at that request and respond, probably with an HTML page. Now, this lookup step all happens behind the scenes, and it's not really something you need to worry too much about. So this type of request, when we type something into the browser and hit enter, that is a GET request. It's made every time we go to a different web page, either by a link or directly typing into the address bar. We're sending a GET request to the server to get a certain resource, in this case, an HTML web page. Now, there's also other types of requests, like a POST request, which is normally used to send data to a server from a web form or something, but we'll learn more address to connect to the server on the host computer with that IP. So then the server will then look at that request and respond, probably with an HTML page. Now, this lookup step all happens behind the scenes, and it's not really something you need to worry too much about. So this type of request, when we type something into the browser and hit enter, that is a GET request. It's made every time we go to a different web page, either by a link or directly typing into the address bar. We're sending a GET request to the server to get a certain resource, in this case, an HTML web page. Now, there's also other types of requests, like a POST request, which is normally used to send data to a server from a web form or something, but we'll learn more about those different types of requests later on. So this communication between the server and the client, the browser, is via HTTP. Now, that stands for Hypertext Transfer Protocol, and it's just a set of instructions which dictate how communication occurs. So if that didn't exist, then they wouldn't really be able to communicate effectively with one another. So this is kind of the same thing as human communication, right? We create languages, for example, English or Spanish, so that people can use those languages to communicate with each other. Clients and servers use the HTTP construct to do that. So then, in Node, we actually write code to create a server and listen for requests coming in from the browser. Now, this is totally different from a language like PHP, for example, where we don't have to create the server manually, and we have other tools which manage that for us, like Apache. But in Node, we manually create the server which lives on the back end of our website. And it's this server that then listens for requests from the browser and then decides what responses to send to the browser, right? So in the rest of this lesson, we're going to be focusing on creating a local server on our computer using Node, which can then be used to actively listen for requests and respond to them. So then the first thing I'm going to do is create a new file, and I'm going to call that server.js, and this is where we're going to create the server. It doesn't have to be called server.js. What you call it is up to you. Now, the first thing we need to do inside here is to require a core Node module, and that is the HTTP module. So I'll say const HTTP is equal to require, and we want to require the HTTP module. All right then, so now we have that, we can use it to create a server. And we do that by saying http.createServer. That is a method that creates a server for us. Now, if we wanted to, we could store this in a constant, and you can call it what you want, and that's going to store the instance of the server in this constant for us, just in case you wanted to use it in the future for something else, like WebSockets. We're not going to do that. I just wanted to show you that you can store the server if you want to, but you don't have to. Okay, so this creates a server, and as an argument, it takes in a callback function. Now then, this callback function is going to run every time a request comes in to our server. So say we request the homepage, if we go to www.mywebsite.com and it sends a request for the homepage to this server, then this function is going to run and send it the homepage. Does that make sense? All right, so inside this function, we get access to two different objects. First of all, the request object, and secondly, a response object. Now, this request object comes loaded full of information about the request, such as the URL that is being requested. So if I go to mywebsite.com/about, I would be able to find that URL from this request object to see where they've come from. Also, other information like the request type, is it a GET request or a POST request, etc. There's other stuff as well, which we'll see later. And also we get this response object, and this is the object that we use to actually send a response to the user in the browser. So we have that. All we're going to do inside here is just log a message to the console whenever a request comes in. So I'll say console.log, and we'll just say request made like so, okay? So we have this server now, but it's not really doing anything yet. It's just floating around in our file, and it's not actively listening for requests being sent to it. To do that, we have to do something else. We have to invoke the listen method. So I'm going to say server.listen like so. And we need to pass in an argument into this, and that is the port number that we're going to listen to. We'll talk about port numbers in a second, but for now we'll just go with 3000 and a second argument, which is going to be local host, and that argument is the host name. Now, the default value of this argument is localhost, but I'm explicitly typing it out. And then thirdly, we have a function right here, and this function fires when we start listening, just so we know that, yep, now we're listening for requests. So console.log, and we're saying here, listening for requests on port 3000. So now we're listening for requests on this host and this port number. But what does that actually mean? So, first of all, localhost. What is localhost? Well, localhost
Physically attracting to someone, your body doesn't wait for logic. It quietly activates a primal system that releases six instinctive signals. What you're just now calling a crush, your body made decisions hours ago. Before your brain had language, you were already meeting it. Signal one, you crave their scent, but it's not perfume. It's pheromones. Your DNA is whispering, this one fits. Second, you offer them food without. That's not manners. That's your biology saying, I'll provide. Three, you start using their slang. Laugh like them. You invite your bitch the same way. That's beer, girl, stinky. A double-sided bolt, which you may have seen before because these bolts are used in machinery and heavy equipment. Since they have threads on both sides, one part goes to the left and the other to the right. Therefore, these bolts are used where a strong and secure connection is needed. The first nut typically connects in the usual way, but the second one tightly binds the nut in the opposite direction, ensuring a more secure hold. This is a double-sided bolt.
is like a domain name that we'd use on the web, a bit like google.com, for example. But this one is one that takes us to a very specific IP address called a loopback IP address. Now, this IP address is 127.0.0.1, and it points directly back to your own computer. So that means that when we're connecting to the localhost domain in a browser, the browser is actually connecting back to our own computer, which is then acting as a host for our website. So the host name localhost means listen for requests coming to our own computer. And this is how we use our own computer as a host when we're developing a website. But there's also one more thing to understand, and that is port numbers. So a port number represents a specific channel, gateway, or port on our computer that a certain bit of software or server should communicate through. For example, on your computer, you've probably got a lot of different software that connects to the internet and receives and sends data. Skype, Discord, mail. mail clients, etc. Now, they will all be doing this via different port numbers to keep information separate from one another. So you can kind of think of port numbers as a bit like doors into your computer through which internet communications can be made to different programs. Now, our server also needs its own port number to communicate through. Now, you're going to see many different values for this port number, but a common one is 3000 for local web development. So, as long as your port number you choose doesn't clash with a port number being used by another program, it's fine to use. So, When we use localhost, we also type the port number after a colon in the address bar after it. So the browser then knows to connect to our own computer via this particular port number, which is where our server is going to be listening. Alright then gang, so we have created now our server right here, and we're also listening to port 3000 on the local host for requests. So now we could start sending requests to this server in the browser. Now before we do that, we actually have to run this file through Node. So let's do that. We'll say node server, which is the name of this file, and press enter. And now we can see listening for requests on port 3000. So that's this console log right here. So now we know that this server is up and running and actively listening to requests, or for requests rather, to localhost port 3000. So now we could go to the browser and we could send a request. But before we do that, notice down here that the process is ongoing. It's still just kind of waiting there for a request. We don't get this path down here waiting for another command because the server is ongoing. And that's correct, because we want it to be running in the background listening for requests. If you want to cancel out of this process to make the server not listen anymore, you can press Control and C, and that cancels out of the process. I'm going to run it again though, because I want to now go over and make a request to the server, because when that happens, when we make a request, we should see this function fire and this logged to the console down here. So let me go over here and go to localhost colon, which means port, and then 3000. So if we press enter, we're not actually going to get any kind of response in the browser, and it's just going to kind of hang. You can see the loading icon up here swirling around, and it's waiting for the server to respond, but we never do actually respond. We do, however, see this logged to the console, request made, so we know that a request has been made and we've detected that. We're just not sending a response back to the browser yet. Now, just quickly, this is logged down here in this console, but not in the console in the browser over here. And that, remember, is because this code is running on the server and not in the browser. So obviously, it's not going to log it to the console in the browser. The code isn't running on the front end. It's running on the back end. And so we see it in the terminal down here instead. Okay? So now we know how to create that server and listen for requests, and how to even fire a function when a request comes in. How do we then actually send a response to the browser? Well, we'd use this object right here, and we're going to take a look at that a lot more in the next lesson. Alright then gang, so now we've created our server right here, and we're saying we want the server to listen to port 3000 on localhost. So when we send requests to this localhost port 3000, then we should fire this function right here. Now, first of all, we need to actually run our file for this to work. So let me do that again. Node server, and now we're listening for requests on port 3000. So if I go over here and refresh this, then we should see down here request made, because this function logs that to the console. Now, what if we make a change to this? What if instead we want to log out, for example, the request object, and the request object contains information about the request that a user sends? So let me do that. Let me delete this and instead log out the request object. And I've saved that. And now I'm going to go to the browser, stop this and refresh. Come over here, and we don't see the request object logged to the console. We just see request made. And that's because every time we make a change, we have to restart our file. It's still running the old file and it's not picked up the code change. So I need to exit out of this process by clicking on the terminal, then pressing Control and C, and that exits out of the process. Now I can run this again by saying node server like so, and now we're listening again for requests on port 3000. This time it will log out the request. The latest code changes. So if I press enter over here, and we should see the request object. Now, it's a huge object with loads of different things on the request object. It contains headers, which is metadata about the request, the type of request, the expected response types, etc. It also contains the URL that a user has visited up here. It contains loads of other stuff as well. For now, let me just log out a few different things from this. So I'm going to say, for example, the request.url and also the request.method. So that is the type of request. Is it a GET request, a POST request, etc.? So let me save this. We have to restart the server. So I've cancelled out of the process by clicking Control-C. Then I'm going to say node server to run this again. And if I come over here and refresh, then over here we can see that this is the URL. It doesn't say localhost port 3000. It's just from the point after that. So in our case, it's just / the root of the website, if you like. And the method is a GET request. So if I try something else, if I go to, for example, / about, then we should see that it is still a GET request, but this time the URL is / about. And this information about the URL is going to be really helpful later when we come to send some responses, because we want to send back a different response dependent on that route. If they go to just /, we want to send back an index page or a home page. If they go to / about, we might want to send back an about page. So we can use that information, this thing right here, later on when we come to implement some kind of simple routing, and we will see that. But first of all, let's also take a look at this thing right here, the response object. So then we also have access to this response object right here, which is what we use to send a response to the browser. Now, at the minute, we're not doing that, which leaves the browser hanging around, just kind of twiddling its thumbs, doing nothing. So we want to formulate some kind of response. Now, the first step in doing this is to formulate the response headers. So response headers give the browser a little bit more information about what kind of response is coming back to it. For example, what type of data we're sending back. Is it text, HTML, JSON, etc.? And we can also use the response headers to do things like set cookies. So let's do that first of all. I'm going to do a little comment that says set header content type, like so. And the way we set a header is by using the response object and then using the method set header like so. Now, we want to set the content type header. There's lots of different types of headers, and I'm going to show you a couple in a second. But I'm going to say the content type. And this could be either text, or it could be HTML, or it could be JSON, like I said. We're going to say, for now, we're going to use text / plain, and that just means we're sending back some plain text to the browser. So I'm going to say the content type, and this could be either text or it could be a header, is by using the response object and then using the method set header like so. Now, we want to set the content type header. There's lots of different types of headers, and I'm going to show you a couple in a second, but I'm going to say the content type, and this could be either text or it could be HTML or it could be JSON, like I said. We're going to say, for now, we're going to use text / plain, and that just means we're sending back some plain text to the browser. So how do we actually send that data back to the browser? Well, again, we use the response object and we use the write method to write to the response. And let's say, for example, I just want to say hello ninjas and send that text back to the browser. Well, I'm writing to the response, but now we have to end the response to say, okay, we've ended this, now send it back to the browser. So we do that by saying response.end. So 3 steps. First of all, we're setting the header for the content type being sent back to the browser. Then we're writing whatever content we want to send back to the browser. Then we're ending the response, which then sends it to the browser. So if I save this, I need to come down here and cancel out of this process and run node server again. Then I'm going to just refresh over here and we should see hello ninjas, this text right here. Let me zoom in a little bit. Okay, so let me just inspect the element right here and then go to the network tab. I'm going to refresh so we can see this request down here. This is the request we've made up here. Now, if I click on this, we can see the headers right here. The response headers are right here. And you can see this is the one that we've set, the content type. But we also have these ones automatically set as well. Now, there are other response headers that we can set manually, and we might see some of them later on. But for now, this is enough. So what if I want to send back some HTML instead of just plain text? Well, the first thing would be to change this to text/HTML. And then instead of just sending a normal string back, we can send back an HTML string. So I could say p tag right here and close the p tag right there. Also, if I wanted to add another line of code, I could do, let me just duplicate this and say hello again ninjas. So first we write the first line of HTML to the response, then we add another line of HTML and it writes both of those one after the other. Then we end the response, which sends all of the resulting code back to the browser. So again, let me save that. I'm going to cancel out of this process, run it again, and then if I refresh over here, we should see hello ninjas, hello again ninjas. And if I inspect, we should see that those are in paragraph tags. Now notice the browser has automatically Added the HTML, the head, and the body tags. But if we were to write our own right here, then it would replace those. And let me just demo that. If I just say up here, response.write, and then inside here, I'm just going to do, for example, a head tag and a closing head. And inside that, we'll just do a link tag like so. And this is going to be rel equals style sheet. It doesn't really need to go anywhere at the minute, but we'll say href is equal to just a hash. Okay, just to demo that this gets added to the document. Okay, so if I save this now and go over here and refresh, in fact, we need to cancel out the process, run it again. And by the way, we will learn of an easy way to do all this so we don't have to keep cancelling out the process and running it again later on in the course. If I refresh now, by the way, we can open the head and we can see that that link tag is right there. So if we create our own and write that to the response, it replaces the default one for us. Okay, so this is how easy it is to actually send a response. But you can already see that this is looking quite messy if we want to send some HTML back. And this is just some very, very, very simple HTML. I imagine your web pages are going to consist of more than 2 lines of text. So this really is probably a bad way to send back HTML because it could get really messy if we add a lot more. Ideally, our HTML pages should be created in a separate HTML file, and then Node could maybe read those files and send them back to the browser. And to do this, we're going to need to make use of the file system again.
Okay.
And then we will speak about lunch. Again, I will ask the same question.
Okay, focus.
Alright then, so we've seen how to send HTML this way, but let's see how we can actually send a full HTML page, a full document to the browser instead, which is a little bit cleaner. So the first thing I'm going to do is create a new folder over here, and I'm going to call that views, and this is where I'm going to store all my HTML. So inside there, I'm going to
What's the bus?
Create an index.html file, and this is what I want to send back to the browser. Now I'm just going to paste this code in so you don't have to watch me type it all out. I've just copied it from my GitHub repo for this lesson, and it's just a simple head with a title right here and a body, an H1 and also an H2. So that's the HTML page I want to now send back to the browser when a user sends a request. So let me get rid of all this stuff here. We don't want to do it that way anymore. We still want to set the header to be of content type text/HTML. But this time we want to send back a file, or rather read a file and then send the data from that file as a response to the browser. Now we've already seen how we can read files. We do that using the core node module fs. So let's require that first of all at the top. I'm going to say const fs is equal to require, and then the fs module. And down here, I'm going to first of all read the file. Let me just do a comment so we know what we're doing. Send an HTML file. And I'm going to say fs.read file. This is how we read files before. And we pass through a relative path to the file we want to read. So // to say the current directory, then into views, then / index.html. So that's what we want to read. Now we fire a callback function when we've read that, and in here we pass two arguments, the error if there is one, and also the data from the file. So inside that function, if there's an error, then we'll just log that to the console. So console.log and error. Now, if there's not an error, at that point, we want to send this data as a response to the browser. So let's say else, and inside here, we want to say res.write, and we want to pass through the data to that, and then we can say res.end to end the response, and it's going to send that data then to the browser, which should be the content of this index.html file. Now, up here, if there's an error, then it's just going to keep the request hanging because we're not ever ending the request. So we should always say res.end here as well, just to end that. So I'm going to save that now, and I'm going to come down here, cancel out.
Sebelum
out of the process in the terminal, so Control C, and then say node server once again to run it. Now, if I go over here and refresh, I should see that HTML page back, which The request, so we should all send it directly into the end method instead. If we were writing multiple things, we might use that, cancel out of this process and run it again, and just demo that this still works, which it does. Awesome. Into response.write, we
Seban request mo. Seban.
we don't actually need this line right here. We can just send it directly into the end method instead. If we were writing multiple things, we might use response.write one after the other, but since we're only using it once, we can just pass it directly into the end method instead, and it still does the same thing. So let me save that, cancel out of this process and run it again, and just demo that this still works, which it does. Awesome. So there we go, my friends. That is how you send HTML pages to the browser.
Welcome to this Kilo Code video. Today I want to talk about an exciting new integration with Claude Code. If you're following Kilo Code releases, you'll know we recently added Claude Code as a provider for Kilo Code. This is really exciting for folks who might already have a Claude subscription and want to be able to use those credits alongside the power of Kilo Code's agentic AI. In the most meta of ways, let's see how to configure the Claude Code provider and ask it to add its own documentation to the Kilo Code docs. To do this, go to Settings, add a new configuration profile, and then select Claude Code as the API provider and click Save. Now, with that provider selected, when we send a request to Kilo Code, it will route it through the Claude Code CLI. This makes Kilo Code a fantastic GUI to pair with Claude Code's excellent API. And it allows you to take full advantage of your Claude Code subscription, all without changing the IDE you use and keeping you inside VS Code. Give it a try today. To learn more, visit kilocode.ai.
AI is changing the game for app development. Firebase is here to help. We offer a platform designed.
All right then, my friends, so we've figured out now how to send an HTML page to the browser. But at the minute, no matter what URL we go to up here, whether it's just the root directory or /about or /blogs, for example, we always get back the same HTML page. Now, that, in my view, would make a pretty shoddy website, and you probably instead want to send back a different HTML page dependent on the route that a user visits. So we need a way to figure out the URL that a user requests, and dependent on that URL, send back a different HTML file, okay? So the first thing I'm going to do is create another file over here, and I'm going to call this about.html. And I'm just going to copy some HTML from my repo again and paste it in. And this just says about at the top over here. And also I'm going to create a 404 page, so 404.html, and we can serve this to users that visit routes that don't exist. So again, I'm just going to copy this from my GitHub repo and paste it right here. So this just says 404, oops, that page does not exist. All right, so now we have those two pages. Now, if a user goes to /about, I want to send back this thing right here, the about page. If they go to anything else other than just / or /about, for example, if they go to /blogs, that doesn't exist. Instead, I want to send back the 404 page. All right, makes sense? So how do we do all that? Well, first of all, let me just up here say we want to figure out the path that a user visits. So we can get that from this thing right here, remember, the request URL. So let me say I want to create a new variable, and I'm going to call this path, and I'm going to set that equal to, first of all, ./views, because remember, the HTML files are inside the views folder, and the path that we want to read is always going to begin with /views, right? And we're going to append to that dependence on the URL. So we can use a switch statement to cycle through the different possible cases. Is it just / or /about or something else? So let me do that. Let me say switch, and then we're going to pass in the request.url. And we're going to evaluate this value. Now, let's add our first case. Is it the case that this value right here is equal to just /, meaning the root of the website? Well, if that is the case, what I want to do is take the path variable and then add to it, so plus equals, and we want to send back the index.html file. So we're just adding forward slash, in fact, let's put the forward slash here. We're just adding index.html to this path, and then that's what we would go out and read, okay? If they just visit forward slash. So then we need to say break right here to break out of the switch. Now, the second case over here is going to be forward slash about. So if they visit that URL, then I want to take the path and I want to append, so plus equals, and it's going to be the about.html page that we send back. Now, let me just get rid of this colon. We don't need it after case. And then down here, we can say break like so. Okay, so if they don't visit any of these, we want to send back the 404 page. So we need a default case to do that. So we say default, and then down here, we're going to say the path is going to be plus equal to 404.html. So then we can break again, like so. Let me just scoot this in a little bit. So how is this switch working? Well, we're setting up this path variable, which starts with ./views/. Then we're looking at the request URL. So do they visit just / or / about or something else? And we're trying to match against one of these cases. If it matches this case, then we're going to add this to the path and then break out of the switch so it doesn't go any further down. If it matches this, the URL, then we're going to add this to the path. And if it matches none of these, it will go down to the default case and it adds this to the path instead and then breaks out. Okay, so we're using this switch statement to figure out what URL a user has visited. And now we're going to take the resulting path and we're going to use it down here to read a file. So instead of hard coding this, we're just going to pass in the path like so. And that's all there is to it. That's a simple routing system set up now. So if I come over here, in fact, we need to cancel out of the process and say node server again. And now if I come over here and go to just the home page, then we should see the home page. If I go to /about, then we should see the about page. If I go to something else entirely, for example, /blogs, we get the 404 page. And it doesn't matter what that is. If it doesn't exist, we get that 404 page if there's not another case for it. So you could add as many different routes or URLs as you want to this way. What that is.
What if I told you your computer could earn you crypto while you're gaming, working, or just watching YouTube?
Is if it doesn't exist, adds this to the path instead and then breaks out. Okay, so we're using this switch statement to figure out what URL a user has visited. And now we're going to take the resulting path and we're going to use it down here to read a file. So instead of hard coding this, we're just going to pass in the path like so. And that's all there is to it. That's a simple routing system set up now. So if I come over here, in fact, we need to cancel out of the process and say node server again. And now if I come over here and go to just the home page, then we should see the home page. If I go to /about, then we should see the about page. If I go to something else entirely, for example, /blogs, we get the 404 page. And it doesn't matter what that is. If it doesn't exist, we get that 404 page if there's not another case for it. So you could add as many different routes or URLs as you want to this way. So then, my friends, one part of the response we've not yet talked about is the response status code. So the status code basically describes the type of response being sent to the browser and how successful the request was. Now, there's many different status codes for loads of different scenarios, but here's some common ones. 200 means that everything was okay with the request. 301 means the resource was moved permanently somewhere, and this is to signify a permanent redirect. At 404, you've probably seen loads of times, it means that the file is not found, so we show probably a 404 page. And 500 means some kind of internal server error. Now, there are loads more status codes as well, but typically they're all in either a 100, 200, 300, 400 or 500 range. Now, those in the 100 range, all those codes are typically informational responses for the browser. The 200 range are success codes, whereby everything goes to plan. 300 range codes are for redirects. 400 range codes are for user or client errors. And then 500 range codes are server errors. So let's now add status codes to our responses. So then, to set the status code of a response is actually really simple. All we need to do is take the response object and then use a property called status code and then set it equal to something, for example 200 if everything is okay. Now at the minute we're setting this status code right here inside the read file method. Now, I don't want to do it here because then we're sending back the same status code for every different request, because immediately after this, we're ending the response. So instead, I might want to set a different status code dependent on the type of response for these different things up here. So I'm going to set the status code in these different cases instead. So let me grab that and let me paste it up here first of all. So underneath the first case, I'm going to say the response.status code is equal to 200 because in this case, they've gone to the homepage and they're getting back the homepage. Everything's okay. Likewise, if they go to /about, the status code is also 200 because everything is okay. They're getting the about page. But if they go to something else and try to access a different kind of page that does not exist, everything is far from okay. And instead, I'm going to change that to 404, meaning that that resource does not exist. And we're telling the browser, look, instead, we're going to send back this 404 page and tell you that the resource doesn't exist. So I'm going to save that and I'm going to cancel out of the process and restart the server because I've changed the code, and then come over to the browser, and then I'm going to inspect over here and go to the network tab. Now, the first thing I'm going to do is go to the home page and press enter, and we can see right here for localhost we get 200. Don't worry about this favicon right now. That's got nothing to do with us. It's just the browser. And then if we go to /about, we should see the same thing, and we can see status 200 right there. But if we go to another page that doesn't exist, now we get a 404 error and we get this page instead. Okay then, my friends, so there's one more thing I want to show you in this video, and that is how to do redirects. So say I had a website and I had a page where I used to have the URL about-me, but then later on I decided actually it should probably be just about. So I changed the URL handler from about me to about, and now this sends back that web page. Now that's fine because on my website I would probably update all of my links to be just /about when they're linking to the about page now from about me, but other websites might still be linking to the about me page because my website's super popular and thousands of other people are still linking to it. Now, when they click on those links, people, they're going to go to a 404 page because that no longer exists. So it would be much better if I could detect requests to this URL so that then I could redirect them to /about. So how are we going to do that? Well, first of all, we need to add in another case into our switch statement right here, and that case is going to be for about-us. So let me copy this case right here and paste it down here and take it back like so. And this is now going to be not about us, sorry, about me. So I want to redirect this to this. How do I do that? Well, first of all, I don't need to append the path because we're just going to do a redirect. And I want to change the status code from 200 to be instead 301. And that means that the resource you're trying to access has been permanently moved, and we're going to do a permanent redirect. And that's what we're doing, right? The about page has been moved from about me to about by me in the past. And so therefore we want to redirect them to this new URL. So we've changed the status code. The next thing to do is the actual redirect, and we do that by using a response header. So we can say response.set header, and the header we want to set is location with a capital L, and the second argument is where do we want to redirect them to? Well, I want to redirect them to just /about. So that's all there is to it. We do still need to end the response, and we do that by saying response.end. And now, if we cancel out of this process and run it again, hopefully if I go to /about me, it will now redirect me to /about. So let's save that and come out here and go to /about me. And now it redirects us to /about, which is much, much better. So then, my friends, now hopefully you can see how Node works as a server and how it can handle different requests to different routes for different web pages, and also how it can send back responses in the form of HTML pages. Now, this way of working right here, using switch and finding out the request URL and all that kind of jazz, that is absolutely fine, but as your websites get a little bit bigger and slightly more complex, for example, dealing with many different request URLs, different types of requests like post or delete requests, and database logic and all that kind of stuff, then this way of working right here might get a little bit messy and hard to maintain. Now, fortunately, there is a third-party package called Express which can help us manage all of this in a much easier and more elegant way. So I wanted to show you all of this way first using raw Node and not Express, because I think it's very important to understand what goes on under the hood rather than just jump right into a framework, click your fingers and let it do all the magic. And also, this knowledge we've built up will actually make learning Express a bit easier too, because we kind of know what's going on under the hood. So we are going to be using the Express package to handle all of our routes, requests and responses later on. But to do that, we need to first understand how to install and use third-party packages. Because Express is a third-party package, we need to know how to use those in Node, and we'll talk about that in the next lesson.